Today we're going to focus on independent and dependent variables on tables and graphs. That's our learning goal. Some jokes. Have you ever been to a restaurant that does not, so this is the lady who wrote on an Instagram post, does not give you change when you pay with cash? My bill was $47.20 and I gave the waitress $100 and she only gave me back $53. I called over the manager, which was our waitress, and she said we don't usually carry change. I told her to give me back the $100 and I'll pay with a credit card. 80 cents would not kill me, but it's the principle. If they do this to everyone that pays cash over a year, that's a lot of money in their pocket. You know, because she can't add. Where did you find that? I've been searching for it everywhere. I created it myself, and there's a jar of happiness. It's time for our daily review. Graph the following. So take a minute and graph this into your notebook, and then pause me and check to see if you have it correct. P minus 4 and 2. Okay, next one. Q 3 and 2.5. Number 4, 4 and minus 5. Minus 4 and minus 5. And S, 4 and minus 5. Okay, so there you go. Hopefully you came up with the same answer as me. Graph the following. List 3 solutions for v is greater than or equal. No, minus 5 is greater. List the following 3 solutions for the following and graph it. So take a minute, graph this, and then check your work. Alrighty, so I'm going to rewrite this as v is less than or equal to minus 5. I know this is a minus 5, so I'll put that on here. And then it's a closed circle. So a closed circle means filled in. So what are solutions for v is less than or equal to minus 5? Well, I know minus 6 is. I know minus 7 is less. I know minus 5 is a solution. So it looks like the pattern's going in this direction. And there we go. Let's take a minute and look at this vocabulary here. Take a minute and copy this down into your notebook, and then we'll talk about it. All right, so hopefully you've had a second to copy these down into your notebook. In a minute, I'm going to give you a visual demonstration of what these things are, but take a minute and just memorize these terms, and then we'll talk about what they mean. The thing that is going to change is our independent variable. The dependent variable is the thing we're measuring in our experiment, and it depends on the independent variable. And our control variables are the things we're trying to control in the experiment. So we'll be referring back to these quite a bit. So we're going to do a little experiment here to kind of demonstrate independent and dependent variables. So we have Bob here. Let's do a black background here, a darker background. So here's Bob. Okay, and Bob is going to run on his track here. And Bob wants to do an experiment. He wants to see which one of his 3 pairs of shoes are the fastest. Now you may say, okay, well, dress shoes and hiking heavy boots and running shoes. Of course running shoes will be the fastest, but Bob doesn't know. So Bob gets on his track, and these 3 things here, if you think back to what our experiment requirements are for independent and dependent variables, the thing that's going to change. So our independent variables then are going to be our shoes. So Bob puts his shoes on, and he goes for a run. Bob runs super fast. He runs on his track, and then he ends up with a time of 27 seconds, 27 and 3/10 seconds. That's his first run, and I'll put that over here. Bob goes back, And this time he's going to try it with his dress shoes. So he puts on his dress shoes. And Bob goes for a run again. He's really fast. There he goes. And he gets to the finish line. And Bob's time is 30 and 2/10 seconds. Bob has one more pair of shoes to try out here. And those are heavy boots. So Bob puts on these heavy boots here. And he sprints as fast as he can. Sprinting. There he goes. There's Bob. Bob does a backflip. Bob lands smoothly. Bob's still running, and he gets to the finish line. But Bob's time was 33 minutes and 33 seconds, and 33 and 3/10 seconds. So assuming Bob didn't do anything fancy during his run, which he did there, that would have made our experiment invalid. But saying he didn't, these are your 3 times for your run today. The 3 times, or the things we're measuring in our experiment, is our, yep, you said it, a dependent variable. So our time in this case would be our dependent variable. So our time depends on our independent variable, or our dependent variable depends on our independent variable, which was our shoes. So other things to consider in our experiment are the type of track he ran on. It's a smooth track. But did he run on the same smooth track each time? Yes, he did. How could you affect his time more? Well, what about if we threw some really tall grass in for Bob? It'd be very difficult for Bob to run through all that high grass. What about the weather? Well, we ran inside, so that's not going to affect Bob's time. If we ran outside, though, there's a possibility that it could be hot, it could be rainy, it could be windy, and those could all affect Bob's time. Can you think of anything else that it could affect Bob's time? What about clothing? Clothing for Bob. Is he wearing a big heavy coat, or is he wearing something that's easy to run in? So all 3 of these things are called, if you look back at our notes, things we were trying to control in our experiment. That's called control variables. Okay. Just some examples. Can you think of any other control variables? Okay. All right, let's do some examples now of All right, take a minute and copy this down into your notebook, this table here, and I'll read the question. A freight train carrying Gina moves at a constant speed. The distance y in miles that the train has traveled after x is shown in the table. What are the 2 quantities we are dealing with in this situation? If you think back to good old Bob, what were his 2 quantities? A lot of times the quantities end up being the independent and dependent variables. Okay, so Bob's 2 things were his shoes and what else? The time, right? How fast he ran. Let's keep Bob up here so he can hang out with us during this question. Okay, so what are our 2 quantities when we're dealing with this situation? Yeah, you guessed it, time and distance. So what happens to Gina's distance as the time increases? Well, the distance keeps going further because the time keeps going further. So which variable depends on each other? Distance depends on time. What is our independent variable in this experiment? Remember, the thing that is going to change is our independent variable. So what is our independent variable? What are we testing? Time. The time changes each time. As a result of the time changing, the distance changes. If we ran at the same time each time, would the distance change? Not if all things were equal. So then, what is our dependent variable in this example? Our dependent variable is our distance. Okay, we got to keep it rolling with our questions here. Using the same table, how far does the train travel each hour? The train travels from 0 to 50, 50 to 100, so they travel 50 miles each hour. What does the equation look like for this table? Okay, so we want an equation that when we put in a number in for x, it will equal y. So let's take a guess here. So y equals, well, 1 per 50. So we'll say 50 is our constant, and then x. Okay, so y equals 50x is what our equation looks like for our table here. Describe how the value of the independent variable is related to the value of the dependent variable. Is it additive or is it multiplicative? It looks like y is always 50 times, x is always 50. It looks like y is always 50 times x. So when you're at 2, it's 100. When you're at 3, it's at 50. So 3 times 50 equals 150. So you can say then, let's look at number 7. Describe how the value of the independent variable is related to the value of the dependent variable. Is it additive or is it multiplicative? It looks like y is always, and again, pause the video and try this on your own. Y is always 50 times x. When it's 2, it's 100. When it's 3, it's 150, and so on and so forth. And it's multiplicative. What are the units for the independent variable and the dependent variable? Remember, our independent variable was time, and that is hours. And our dependent variable is distance, which was equal to miles. What is the unit rate for the table? Well, we already answered that earlier when we asked, we already answered that, and that was 50. That's the unit rate. Remember, a unit rate is per 1. And our teacher has 20 pounds of clay but wants to buy more for a clay class. The amount of clay purchased by the teacher and the amount of y available for the class is shown in the graph. If the teacher buys 10 pounds of clay, how much will be available for our class? So we start with 20 pounds, and then we increase it by 10. You can use the graph here. Start with 20 pounds. We increase it by 10 here. And that is going to give us 30 pounds. Now, if the art class had a total of, okay, next question. If the art class has a total of 50 pounds of clay available, how many pounds of clay did the teacher buy? How can you use the graph to find this information? So if you go to 50 here, go over, you can see it equals 30. So you can say that you start at 50, and start at 50 and go to that point, next in line, and that is 30. See, 30. So our answer is 30. And our teacher has 20 pounds of clay but wants to buy more clay for her class. The amount of clay X purchased by the teacher and the amount of clay is available for shown on the graph. What are the two quantities in this situation? Our two quantities are the clay purchased and the clay available. Next question. Which of these amounts depend on the other? The amount available to the class depends on how much is purchased. What is the independent and dependent variable? The independent variable, if we think about our definitions, is what's changing, the thing that's going to change. And the dependent variable depends on the independent variable. So what is going to change? The amount purchased by the teacher. That is our IV, our independent variable. So what is our dependent variable? The amount available for the class. Because the amount available for the class depends on how much he purchases. Today we learned about independent variables and dependent variables. Thanks for tuning in.